So this is the blubber balls or potty putty experiment. What do you need? You only need a few things for this. You need PVA glue. Now PVA glue, actually the PVA stands for polyvinyl acetate. Now you don't want to write that on the bottle. So PVA glue is white glue. Schools use this all the time, particularly primary schools, secondary schools. Ask the art department, they're bound to have some. It's just ordinary, plain, washable PVA glue. So make sure it's washable, because there are different types. You want the washable one. You can actually buy this in ordinary stores, so stationers sell it because artists use it, do-it-yourself shops sell it, hardware stores sell it, so you can get it from anywhere really quite easily. You can get it in different containers. As you can see, I've got a couple of different versions here. I'm going to be using this one. Then you need something rather more interesting in some ways, called borax. Now borax is its shortened name, and borax actually is sodium tetraborate decahydrate. Now you can see why we shorten it. So you won't normally need to ask for it by that complicated name. Borax is what it's usually known as. And you can get this from, sometimes they sell it in hardware shops, sometimes they sell it in drugstores and chemists. And sometimes those shops will order it for you if they don't have it in stock. I don't normally have a problem getting it from those shops myself. Some people tell me gardening shops sell it. I'm not quite sure what they do with it, but apparently they do. It's a household cleaner. So if you go into a shop and they're not quite sure what you're talking about, so I know borax is an old-fashioned household cleaner because it used to be used by your great-grandmother. And apparently to wash her hair as well, with egg yolk in it. Anyway, what we're going to do, I'm going to pour some of this borax into this bowl of water I've got in front of me. I'm using slightly warm water. It doesn't have to be very warm, just slightly warm because it works better. We're going to make a solution. We're going to mix this with the water, and it goes into solution a bit more easily if the water's a bit warm. Now we've got about 3/4 of a litre of water in here. Now it doesn't actually matter how much you use. I'm using a bowl this size because I need to get both my hands in a minute. You're going to see what I'm going to be doing. I need to get a good sort of grip in there. And I've got quite big hands. You might find it easier doing a smaller bowl. So you need about 1 heaped teaspoon for every 250 ml of water. Now remember, I told you I've got about 3/4 of a litre, which is 3 times that amount. So I'm going to put 3 heaped spoons in. But it doesn't matter if you go over, actually. Now, what I'm going to do is mix it up. And I'm going to stir it around. Because what I'm doing, remember, is making a solution. Now you'll notice it's gone all cloudy. I'm hoping that the borax powder will dissolve away. And by putting so much in, what I'm actually wanting to make is something called a saturated solution. Think of the word saturated. So much stuff, like if you get your clothes saturated in the rain, it means water starts dripping out. You've got so much in it, it starts dripping out. Similar meaning here, we've put so much powder in, we've saturated the water with powder. And we know that's going to be true because what we're going to do, I think I'm happy that it's dissolved. I'm now going to leave that just for a few minutes to let the powder that doesn't dissolve, because there's so much in it, not all of it's going to dissolve, remember it's saturated, some of that powder will now reform and collect in the bottom of the bowl. But it does take a few minutes, and I recommend leaving it for about 5 minutes to let the powder settle down. And as long as you see some powder settled in the bowl at the bottom, you know you've made a saturated solution. If it hasn't, you put some more powder in, okay? So if you leave it for 5 minutes, it goes nice and clear, you don't see any in the bottom, put another heaped tablespoon in and give it a stir and leave it another few minutes. So we're now 5 minutes in. It's cleared a little bit, and remember, it doesn't have to be totally clear. Remember what we wanted. We just wanted to see some of the powder that we put in there settling on the bottom, which suggests to us it's actually a saturated solution. Now, we get our glue, remove the lid, and what I'm going to do is pour a stream of the glue into the water, and I'm going to spread it around the surface nice and thin. So let's see how we get on with that. I'll start squeezing slowly. That's it. Just spread it all over the surface, a very thin stream. I want it thin because I want the glue to come into contact with the liquid as best as possible, and having nice thin streams is the way to do it. Now, of course, I'm not measuring this. A scientist really would measure it exactly, and you might choose to measure it. What I suggest you do is put in about 2 tablespoons full of stuff. Now, I've probably done a bit more than that, but that's okay. Now, I'm going to leave that there. Now, remember, this is glue. You saw it's liquid. I'm now going to prod it a bit, because I want it to make sure it does touch the borax solution. Don't want it to go too far in, and then I'm going to fish it out. It's pretty disgusting. And then I'm going to try and get it into a little ball in my hand. Now you'll notice how I'm doing this. I'm dropping it from hand to hand and squeezing it gently. Just squeezing out a bit of the excess water between the fibres that I pulled out. Now, so far so good. Now what I'm going to do is I'm going to put this down because I need to dry my hands. They're a bit slimy and slippery because this is like washing up liquid now. And so I'm going to put it down. But already you can see it's looking a bit different to when it came out of there, isn't it? So let's put it down. And when you do put it down, make sure you put it down onto a nice smooth surface. Putting it on a plate or a saucer is probably the best. Or if you've got something like this in your kitchen, a nice smooth shiny surface, put it onto that. Definitely do not put it onto a cloth because it will ooze into the fabric and you won't be able to wash it off, okay? So I'm going to put it down there and I'm going to get some tissues and I'm just going to dry my hands quickly. You don't want to take too long over this. So dry my hands, and by doing that it means that when I pick it up again, my hands, of course, are not going to be so slimy. I'm going to find it easier to handle the ball. And by the way, if you look carefully, that ball has started collapsing. It started flattening out on the table, which might give you some clues about some things you can try a bit later. Now, okay, not too bad. I'll finish it off here. Now you know why we wear lab coats sometimes. Jolly good. Right, now I'm going to pick it up again. That's better, and my hands are of course much drier now, easier for me to handle this stuff. And what I'm going to do, as you can see, I'm going to carry on doing this for a few minutes. And what I want to do is actually start rolling it, okay? So this is what we're doing. I'm going to start rolling it. Just move it around. Now this takes a few minutes, okay? So I will tell you straight away, a few minutes. And what we want to do is roll it around in our hands. And I recommend probably rolling it quite fast, like I'm doing it, but don't push too hard. Okay, so just roll it around in your hand like this. And you'll notice the size of the ball here. The reason we need to roll it around for a few minutes, by the way, is because I'll tell you a little bit of what's happening right now. There's a chemical reaction going on. I'm going to talk a bit more about that afterwards. But there's a chemical reaction going on between the materials we've used. And that chemical reaction isn't really fast. It takes a few minutes to do what we want it to do. So usually 4 or 5 minutes. You know when you're getting near to being complete because it starts looking much more smooth and much more shiny, a bit like a glass ball, a white glass ball. It looks something like that. It'll be nice and smooth. Another thing to remember is the bigger the ball you make, the longer it takes for it to work, usually. The bigger the ball. So now we have a ball after about 5 or 6 minutes, and let's see what happens. What I want you to do is to take your ball and drop it onto a smooth surface. So let's see what happens for my one. Watch carefully. So we have a bouncy ball. Now of course I'm just bouncing mine on the table here. I wonder what would happen if we bounce it off the wall. So I'll go over to my wall here and let's see if it works. Ooh, ooh, very good. Boom, not bad. Boom, not bad. So a bouncy ball. So how can we turn a sticky oozy glue into what appears to be a rubbery bouncy ball? Well, let's think about what was going on. I already gave you a clue when I was rolling it that there was a chemical reaction going on in there. So let's think about that. We got the PVA glue. Now PVA glue, if we could see it under a microscope, and it'd be a very powerful microscope, there'd be lots of tiny chains of particles of the glue stuck together in what we call molecules, stuck together in little chains. And there's millions of them in this bottle. And they're quite long, under a microscope, be quite long, of course, they're microscopic here, but there's so many of them, they're all moving around each other in water, so that's why the glue flows. So they're moving around in water. Now, when I squirt this PVA glue into the borax solution, remember I told you wanted a nice thin stream because I wanted as much glue as possible to be touching the borax solution. Now, the borax solution is dissolved borax, as you saw, and when we pour the glue in, what we think is happening is the particles of borax, the borax molecules, are going up inside all those thousands and thousands of little tiny chains of molecules of PVA and starting to link them together. So they link together in all different ways, some side by side, some crossing over. They start gripping each other and linking together, and so don't flow so easily and become more rigid together. Also, of course, there's water around. We've got more water in here. That's already got water in it, and we start trapping some of those particles of water, the water molecules as well. And that's one of the reasons it goes a bit shiny. So, borax molecules cling and react with the PVA glue and start joining it together. And that was the chemical reaction that I was talking about, the chemical reaction between the borax particles or borax molecules and the molecular chains or little molecules in the PVA, starting to link them together and join them together so they become more rigid, and that's why it does that. But notice it did take a few minutes, didn't it? And once it's like that, we can turn it into a little ball. Now remember, when they form like this, one way scientists describe the tiny molecules in here are called elastomers. Think of the word elastomers. Remind you of anything? Like elastic bands? Called that for a similar reason. Elastomers, you can change their shape a bit and they go back to the same shape as long as you don't pull them too much. And that's what happens here when we bounce it. You change their shapes a bit but not too much, and they just go back to the same shape again, and that's why the ball bounces. Okay? So what about some things you can vary to see what would happen? The first thing that comes to mind actually is how about changing the shape? Don't actually keep it as a ball. We've already done it as a ball. How about using your fingers and very gently change its shape? For example, albeit just with my fingers, into more of a cube shape. And this would be a bit of a rounded cube, admittedly, because my fingers are a bit rounded. But maybe get it into a cube shape and then drop that from different ways and see how it bounces. That'd be interesting. Will it bounce differently from a ball? And of course you can actually get it back into a ball shape by rolling it. What about stretching it? What about if you pull it and stretch it? Of course this does stretch, which is interesting, isn't it? Look, you can stretch it. I wonder how far it'll stretch, that's interesting. And will it go back to the same shape again? Well, some of it I can do for you. What about making different size balls? Remember when I was mixing it right at the start? I was talking about this, about it takes longer for a bigger ball for the chemical reaction to take place. How about using much smaller pieces? So make the smaller ones and bounce them and see if they bounce the same as the bigger one. Or maybe make an even bigger one. I must admit, the very first time I ever did this experiment, the one I made was rather large. It was about a big tennis ball size. And it did work, it was great. I was bouncing it all over my house. So what other things could you try though? And did it bounce differently from this one is an interesting question. What about changing the solution? Remember we made a saturated solution, so we put so much powder in that some of it collected on the bottom. How about not making a saturated solution? So do you remember in here we've got about 3/4 of a litre of water and I put 3 heat tablespoons in. So maybe only put 2 heat or 1 heat. So change it, see what that does. You can colour these, by the way. I mean, white I like, but you might want to colour it, and green would be a good colour I think for this sort of thing, but any colour you want. If you're going to put colouring in, use food colouring and put it in the glue itself, not in the water. You can try it and you'll see the difference if you do. One last thing I'm going to show you now. I already did it earlier. I stretched it. It does stretch quite easily and when you pull it slowly, doesn't it? So it stretches. But watch what happens if I pull it quickly. Watch really carefully. Watch. Quickly. It snaps. Interestingly, I don't know if you can see that, it's pretty solid inside, isn't it? It looks pretty solid there. And the chemical reaction's been going on inside too. We can actually sort of push it back together, but I've got to be honest, because most of the chemical reaction's already happened, so in other words, most of the borax and PVA particles are already joined together, it won't ever go back as if it had never had a crack there at all. There'll always be a little crack there, even inside of it. And we can sort of get rid of it by giving it a good squeeze like it was a plasticine ball or maybe a ball of blue tack. But I think if we opened it up and looked with a microscope, you would actually still be able to see where I joined it back together, because they're never going to join back exactly the same. But right now, it looks pretty good. And I'll tell you one last thing I think you could try, which would be really interesting if you've been playing around with this. And you can still see the crack there, actually. You can see the lines that I've still made on there, can't you? I'm actually going to leave this now on a surface. So put it when you finish playing with it, just put it somewhere and just maybe leave it there for a little while. And every now and again, go and have a look and see what happens. So I'm going to leave mine over there and let's see what happens.